For this lesson, we're going to be discussing dependent and independent events. So let's start with a few definitions. First, a compound event. Compound events involve two or more separate events. For example, if we're flipping a coin repeatedly, where the first is the first event, then the second flip is the second event, etc., etc. Now, if I'm looking at the probabilities of what's happening with multiple events, we call this a compound event. So, in situations that involve these kinds of compound events, these events may be independent or dependent. Independent events are events in which the outcome of one event has no effect on the outcome of another event. So regardless of what happens in event 1, the probabilities are the same for event 2, same for event 3, nothing changes. Now for dependent events, these are events in which the outcome depends directly on the outcome of another event. So depending on how the first event went, this changes the probabilities of outcomes in the second event. So what we're going to do first is just think about some events and try to determine if they would be independent or dependent. So here we have smoking and lung cancer. Could those two things be dependent on each other? Absolutely. So these would be an example of dependent events. Next, tossing a coin and then rolling a die. If I toss a coin and it lands on heads, does this in any way change the possibilities or the outcomes of me rolling a standard die? No. So that's an example of an independent event. For C, drawing 2 cards from a deck without replacement. So again, this word without replacement comes in. This is still very, very important. So if I remove a 5 of hearts, now there's one less card in this deck, there's one less 5, and there's one less heart in this deck. So that absolutely changes my probabilities of what that second card can be. So this would be dependent. So we have some rules here for independent events. So when I'm looking at a situation, it's really important that I think to myself, are these events independent or are these events dependent? If I determine that they are independent events, I can use the product rule. So if A and B are independent events, the probability of A and B happening is the probability of A multiplied by the probability of B. Now recall that that little upside down U shape means and, so this is when they both happen. Now because they're independent, I can just multiply their probabilities together. This is because if event A happens, it doesn't change my probability for B, so I can directly just take those probabilities and multiply them. So let's try a couple of examples. For example 2, what is the probability of rolling a 5 and then rolling a 3 with the same 6-sided die? Now to start, we want to think to ourselves, are these independent or dependent events? If I roll a 5, does that change the likelihood of what I'll roll the next time? No. So these are independent events. So what I'm going to do is I'm going to define my events. So event A will be rolling a 5. And event B will be rolling a 3. Because these are independent events, in order to find the probability of rolling a 5 and rolling a 3, I can multiply my two probabilities. So my probability of rolling a 5, there's 1 5 on a single die out of my 6 possible outcomes. And we can multiply that by the probability of rolling a 3. There's 1 3 out of my 6 possible outcomes. And that gives us a total of 1/36. So that's our first example. Let's try another one. What is the probability of rolling a 6 with 1 die and then drawing a 6 from a deck of cards? Again, we think to ourselves, are these independent? If I roll a 6 with a standard die, will that in any way influence my probability of drawing a 6 from a deck of cards? No. So these are definitely independent. Let's define our events. So event A will be rolling a 6. And event B will be drawing a 6 from a deck of cards. So because they are independent, my probability of them both happening is my probability of the first one happening multiplied by my probability of the second one happening. So my probability of rolling a 6, there's 1 6 out of 6 total outcomes. And then my probability of drawing a 6. So a 6 is 1 out of the 13 kinds in a deck. So then I can multiply that and I will get 1/78. There we go. So let's try one that is a little more difficult here. The probability that the Toronto Maple Leafs will win their next game is 0.4. The probability that the Toronto Raptors will win their next game is 0.65. What are the odds that the Raptors will win and the Maple Leafs will lose? So a lot going on here. So the first thing that we need to do is we need to think, are these independent or dependent events? So if the Maple Leafs win, that's a totally separate event from the Raptors winning, so these would be independent events. So let's define our events. So there's our two events, and we're given some information here. So we're given that the probability of the Leafs winning is 0.4. Our probability of the Raptors winning is 0.65. And we'll also find the probability of B complement. That's because we're looking for the odds that the Raptors win and the Maple Leafs will lose. So we will need some complements here because we're finding odds. So probability of B complement will be 1 minus 0.65, which is going to give us 0.35. And we'll also find the probability of the Leafs losing, 1 minus 0.4, which is 0.6. So this is everything that the question has given us. So what we'll do is we'll first start by finding the probability that the Leafs win and the Raptors lose. And we want that to look like this. So we'll have, we want to find the probability that the Leafs lose and the Raptors win. Sorry, I misread the question. So that will give us 0.6 multiplied by 0.65 because they are independent events. And that will give us 0.39. So this is the probability that our Leafs lose and our Raptors win. Now, because we're finding odds, we also need to find the complement of this. So that would be our probability of the Leafs losing and the Raptors winning complement. So 1 minus 0.39, and that will give us 0.61. So our odds will be 0.39 to 0.61. Now we don't like having decimals in our odds, so we're just going to multiply both of those by 100 to have 39 to 61. Now for our next example, if Mickey asks Minnie on a date, there is an 85% chance that she will say yes. There's a 60% chance that Mickey will be too shy to ask Minnie on the date. Now we want to determine the probability that they'll be going out on Friday night. So let's start by identifying our events. So event A is that Mickey asks. And event B is that Minnie says yes. There we go. So our probability of B, of Minnie saying yes, is 0.85. And our probability of Mickey asking is 1 minus 0.6, which is 0.4. Now, we can treat these like independent events as long as we ensure that we have the right probabilities going in. So we figured out our probabilities. So our probability of A and B happening will be 0.4 multiplied by 0.85, which is 0.34. There we go. Right, last example. On the drive to school, the probability that the first stoplight will be green is 0.6, and the probability of the second light being green is 0.3. First, we'll illustrate the outcomes in a tree diagram. So, for the first stoplight, it could be red or green. So my probability of the first one being red is 0.4, and the probability of it being green is 0.6. I just got that from here. So the probability that the first stoplight will be green is 0.6. So the complement would be the probability of it being red. Then from there, we could have red or green for the second one, and red or green for the second one. So the probability of the second light being green is 0.3. So that means the probability of the second one being red is 0.7. So here are my outcomes. Red, 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 green, green, red, or green, green. So we want to determine some probabilities here. Determine the probability of 2 green lights. So the probability of 2 green lights, because these are independent, we can just multiply them. So 2 green lights would be here, 0.6 and 0.3. So that would give us 0.18. And then 1 green light. So that means we could have the probability of red then green. Or, so we add the probability of green then red. So red then green would be 0.4 multiplied by 0.3. Or we could have green then red. So 0.6 multiplied by 0.7. And that will give us 0.12 plus 0.42, which will give us 0.54.